big takeaways. All right, the process by which an unstable nucleus emits particles. Okay, the process by which an unstable nucleus emits particles. Emits like, yeah, emits particles and energy in order to change it to a different, more stable atom. Okay, so I'll let you guys copy that down if you guys are taking any notes today. The process by which an unstable nucleus emits particles and energy in order to change into a different, more stable atom. All right. So for example, carbon, remember the top number is the mass number. Its mass will change to create a more stable element. Okay. So you don't have to write this example down. I'll go over more examples here in a minute. So hopefully you have the definition down. Now, there are 3 types of, oh, what happened? There are 3 types of radioactive decay that we're going to be looking at. Oh, got unplugged. There we go. All right, the first one is alpha decay. So we have alpha, and that's what we're going to be talking about. All right, so we got alpha decay. I'm going to get a piece of paper over here. Perfect. So alpha decay, it emits 2 protons and 2 neutrons. Okay, in the form of a helium nucleus. So if you look down here, well, I'll zoom in a little bit. If you look down here, hopefully you guys remember writing that type of outline. So it's called a 4-2 helium. So that is an alpha particle. The bottom number means the number of protons. The bottom means the number of protons. The top number is the number of protons plus the number of neutrons. Okay, so the bottom number is the number of protons. So we emit 2 protons and 4 protons and neutrons, like combined. So if we have 2 protons, that means in this example there were 2 neutrons because 2 plus 2 equals 4. And that's an alpha particle. That's an alpha decay. Okay. So what this kind of looks like, emitting means you're kind of getting rid of. Okay. So if you look at this example, if you look at this example on the right, what it shows is it shows 240, 94, Pu. Okay. And when you emit an alpha particle, it's kind of like you're going to subtract it. You're getting rid of an alpha particle. So you're going to subtract a 4-2 helium, and that's an alpha. Okay? When you're emitting, you subtract. Okay? So what this does is you look at the top number. What is 240 minus 4? Well, 240 minus 4 is 236. And then you have 94. Let's look at the bottom numbers. 94 minus 2. 94 minus 2 is 92. Now, what you notice is the number of protons changed and my mass changed. whenever the number of protons change, that creates a new element. So now what you're going to have to do is, what element is 92 on the periodic table? Well, hopefully you have a periodic table, or you can Google it, and I'm pretty sure it is uranium. So that would be your final answer. Okay. So that's an alpha particle. That's alpha. Okay. Let's see. And here's another example. All right. Here you actually, it's plus on the other side, but if you look at it, let's walk through it. So you have 222, 88 radon, okay, minus an alpha particle, minus a 4,2 helium. In this example, they took helium to the other side, so they just added it over to the other side. But it's the same thing. It's the same thing. I like subtracting it because it's emitting, okay? So 222 minus 4 is 218. 88 minus 2 is 86. All right. And now on the periodic table, you're going to have to see what element 86 is. Okay. Let's see. I don't have a periodic table in front of me. Oh, that is it. Radon. Oh, radium to radon. And so that would be Rn. And that's your final answer. Okay. So that's an alpha particle. Alpha is a 4,2 helium. Okay. Next, we're going to look at beta. Beta. Okay, so beta. Okay, it doesn't show it. Beta, I'm going to do it on this piece of paper, is a 0 -1. And then this, you can either do an electron, or I like to do, that's the beta symbol. It's kind of like a B on a stick. It's kind of like a B on a stick, and that's the beta. Okay, 0 minus 1. So remember, the top is the mass number. So that's the number of protons plus neutrons. And that's the bottom number. Oh. What happened? There we go. The bottom number, my screen froze, sorry. The bottom number is the number of protons. Okay. So -1, so we actually lose a proton. Interesting. So if you look at an example, we have 228, 88 radium, okay? And we emit a beta particle, okay? So when we emit, we subtract, right? Always subtract. And you subtract a beta, so a 0, -1, beta. So that's what our problem kind of looks like. Okay? So what is 228 minus 0? Well, 228 What is, oh, this is a little tricky. What is 88 minus a -1? Well, when you subtract a negative, it actually turns into a positive. So you have 88 plus 1, which is 89. And once again, you're going to have to see what element 89 is on the periodic table. And element 89 is AC. So that's kind of what a beta particle looks like. Okay. And here's another example of what it will look like. Okay. And once again, if you have any questions, please unmute yourself and just ask. Feel free to stop me at any time. All right. Now, the last one is a gamma. Now, gamma I like to call as the ghost. All right. Because gammas don't have any effect. All right. So gamma is represented by a Y, and it's a 0, 0. Okay, it's a 0, 0 because they're such high energy. They have no mass and they have no charge. All right, but they're always paired with a alpha or beta. So whenever you see an alpha, and whenever you see a gamma, you know there's going to be an alpha or beta. Always paired with alpha or beta. Okay, always paired with alpha or beta. So in this one, let's look at this example. Once again, they added it to the other side, but I'm going to write it out. So you have 226, 88 radon minus. So this undergoes, what's a 4,2 helium? Ooh, that's alpha. Very good. 4,2 helium minus a 0, 0 gamma minus 0, 0 gamma creates. Oh, this is kind of a long problem. If you look at this, so 226 minus 4 is 222, minus 0 is once again 222. Let me zoom out a little bit. There we go. 88 minus 2 is 86, minus 0 is still 86. And then you'll have to look up what element 86 is, and that is radium. And that's how you calculate alpha, beta, and gamma reactions. Okay. And here's the last chart. So we talked about the symbols. You know the 4,2 helium, the 0, -1 beta. You can either do E or B. That's fine. And then gamma kind of looks like a Y. The masses. All right, here's the masses. I would write down this chart just because it's pretty handy. Yeah, okay. Now, if you look at the charge is actually pretty interesting because the charge is the number of protons. So in helium up here, you have two protons, which means you have a positive 2 charge. In the beta, you lose a proton. When you lose a proton, you have a -1 charge. Okay, and then there's no mass or charge in gamma. Now, penetrating power, which is the strongest, alpha, beta, or gamma? Well, in this example, in all of these, gamma is the strongest. All right. So whenever you hear radioactive decay or radiation, gamma is the strongest. All right. Gamma can actually travel up to about 10 feet. It can travel a decent amount. Whereas an alpha particle, an alpha probably won't even penetrate like paper. All right. It's actually, yeah, it won't even penetrate paper. All right. So I'll give you a second to write that down. Okay, let's see. Do you guys need more time or are you guys good? Sweet. All right, so that is everything I wanted to go over. All right, so hopefully we know alpha, we know beta, we know gamma. Okay, so what I did was in Google Classroom, what you can find under the classwork tab. Okay, under the classwork tab, you can find decay practice. Okay, click on decay practice. What it takes you to is this. Okay, this was the chart. Hopefully you just copied down, right? That was the chart. Okay. Then after this, you're going to organize them based on where they, so which one's the most penetrating? So A, the most penetrating is gamma, so you can just put A right there. B, which one's the least penetrating? Well, you know, that's alpha. C, particle that has no mass but a negative charge. Well, hopefully you got that's beta. All right, so you're gonna just fill in these, okay? And then here, you're gonna solve for what's missing, all right? What's missing? All right, identify the type of decay and complete it, all right? So A, what is missing here? Well, we go down by 4, and the bottom number goes down by 2, so you know that has to be an alpha decay. Whereas B's interesting. I know it's a beta decay, but what originally was over here? Okay, what originally was over here? All right, so what you have to do is you can look at the top, so 14 plus 0, and then 7 minus 1. Okay, so you know it's going to be it's hard to do over and top, so you know it's going to be a 14, 6, and then what element is number 6? Well, I can do a little division, I guess. I'll do that. 14, 6, and element number 6 should be, all right, and then you'll just solve some problems at the bottom, okay? When you're doing like a little fraction like that, I would do it like this, 14, 6. That represents the top number, 14. 6 represents the bottom number. Okay? Alpha decay, well, write the nuclear equations. All right? So when you get down to number 4, write the nuclear equations for the following decay processes. Alpha decay of radium-226. So you know you have 226. What element number is radium? What element number is radium? I might have to look that up. '88. So what you can do is 226, 88. And it undergoes an alpha decay. So when we do that, we subtract 4, 2 alpha, right? And what does that equal? Well, 226 minus 4. Hopefully you got 222, 86. And that's going to be right. All right, so hopefully you can work this out. It's kind of harder doing it on the computer, but you should have all the resources you need. If you would rather use Kami, that would be fine. Did that kind of make sense? So we still have about 40 minutes left of class. So the rest of the time is for you to complete that. I will stay on the Google Meet. If you guys have any questions, I will be here. You don't have to stay on the Google Meet. That's up to you. So remember, Friday, I will post a little activity for you guys to do. But there is no Google Meet, okay? So yeah, if you don't have any questions, I hope you guys have a fantastic day, and we'll see you in class on Monday.